apoptosis is to turn on the XIAP gene to stop stop caspase activity. Okay. However, the cell, knowing that there's going to be an inhibitor of apoptotic proteins, an XIAP or something somewhere in the cell, has a way of blocking the activity of these IAPs. Okay? And it happens to involve another protein in the mitochondria that also exits with the through a VAX. Okay, what? You know the name of that
I'm
protein?
trying to figure out where to draw it now.
Oh, I'm sorry. We're kind of running out of space, aren't we? Okay, this protein, everybody will remember the name of this protein. This protein has two names. My preferred name is SMAC. The other name is Diablo. It's the same protein. Two different labs, and you wonder where in the world did they get those names? Why did one lab call it SMAC and the other lab call it Diablo? But SMAC Diablo. Okay? And I can't remember how it does it. It's an inhibitor of ubiquitin ligases, but it's released just like cytochrome C is released, and its job is to knock out the ubiquitin ligase activity of the IAPs. Okay? So I think it's interesting that the mitochondria is involved in this bizarre war. I mean, we've got soldiers of all kinds fighting a battle to either keep the cell from committing apoptosis or to make the cell commit apoptosis. So the change in one apoptotic protein, you know, if we see an automatic increase in VAX, because MYC increases the amount of VAX, it doesn't mean the cell's going to commit apoptosis, because look at all of the other things that are going to be influencing whether or not apoptosis is taking place. So let's see. I'm trying to think. There's something else I wanted to mention and completely forgot. This may be just enough point to mention everything on my page. Oh yeah, there's one thing I want to go back and look at.
I thought that SIAP isn't going to be active until it's activated by something.
Yeah, its gene is activated. Its gene is activated by NF-kappa G. But we're thinking that, well, I was kind of hoping or thinking that maybe simvastatin inactivated NF-kappa B, so that XIAP would not be made and the cell is more sensitive to apoptosis.
Yeah, what I'm saying is, since SIAP needs NF-kappa B to be active, why do we need SMAC to smack it down?
Smack it down.
Why do we need SMAC to block the XIAP?
That's just another one of those balance things, you know. So one signal might say commit apoptosis, and another signal say, well, not now, for heaven's sake. Let's see if we can resolve the issue. So sometimes there are competing signals, and a lot of times the anti-apoptotic signal is, well, don't die now. Let's just see if we can resolve the issue. So you might turn on the ER stress apoptotic genes, but there's going to be other proteins that say, well, not now. Can we just kind of hang on a little bit and see what's going on? And same with the virus infection, too. So, but you're right. I mean, it does make sense. That seems crazy that the cell would have transcription factors controlling these, whether or not these things appear. And at the same time, we've got SMAC and Diablo controlling whether or not those things are active. So I would say that one's controlling gene expression, but the other one's controlling the ubiquitin ligases that are already present. So you can get a more rapid inactivation. And the NF-kappa B thing would be a slower responding signal. Okay, any other questions about this? Because this is basically it. And you're going to find, and I will cover a little bit more next week, but I think you're going to find, if any of you are doing any apoptosis papers, that your particular set of proteins, it might not be BID, it might not be BIM, it may be PUMA or NOXA, are doing approximately the same kinds of things. Is just replace, for example, you replace BID with BIM, or you replace BID with Puma. But one of the things I wanted to go through, and this, then, I am done, I think that's all okay.
So is the, did you say T cell? Like, the thing, is that just a T cell?
Yeah, oh, that's what, wait, I'm not done yet, I got a couple more things. Then, okay, but you remember, so, Brian's issue, now that you asked that question, it reminded me of the one other thing I forgot to tell you. Okay, what was your question about the cytotoxic T cell?
Okay, that's what it's called. Oh,
Yeah,
oh.
cytotoxic T cell. Okay, so, every once in a while, you can get some pretty nasty consequences if the cytotoxic T cell sticks around and remains active for a long time. You guys talk about what happens when cytotoxic T cells continue to stay active? Oh, okay. Well, eventually, and this is a delayed response, you gotta get rid of the cytotoxic T cell. And it's going to commit apoptosis. And a cytotoxic T cell will eventually, but not immediately, in a delayed way, create its own FAS. Okay? So you end up with kind of like auto-inducing cell death. Okay, and then the cytotoxic T cell dies. And you get rid of that population. Oops, I spelled that wrong. Okay, so that you don't have prolonged inappropriate activation of the cytotoxic T cell. These are to be active for a couple of days, not in any chronic way at all. So in a delayed way, the FAS receptor is eventually made by the cytotoxic T cell, and then the cytotoxic T cell can commit apoptosis. Okay, melanoma cells some of them have been shown to turn off their FAS gene and turn on the FAS ligand gene. Okay, so when the cytotoxic T cell contacts the melanoma cell, the cytotoxic T cell is the one that's committing apoptosis, not the melanoma. Okay, so this is a one way that some cancer cells can evade the immune system. You can turn on the immune system by expressing their own FAS ligand and turn off their FAS receptor. And that's been known, I think that one's been known for quite a long time. Okay, and then one more trivial piece of information that might be helpful for some people who are putzing with apoptosis in their final papers. Oh no, this is MCL. That's MCL. The activator BH3 only protein, BID, BIM, and Puma. These are the, by the way, these are the activator BH3 only proteins. These guys can contact any one of the anti-apoptotic proteins in the BCL, that anti-apoptotic BCL2 family list. So they're universally functional, okay? They're also activators, so their main job is to get back into the mitochondrial membrane. Okay, however, bad is not that, is not that universal. It can only inactivate or bind to and inactivate the BCL2, BCLW, and BCLXL. And NOXA, one of the P53 target genes, is only functional of MCL and A1. Okay, so you might run into some specificity issues if you're doing apoptosis. So I kind of better throw that in. Okay, and then one announcement, we found out today that there's going to be a guest lecturer on Friday, December 2nd. I think that's right after your test, right? Yeah. From 2:10 to 3:10, so that means that those of you in molecular genetics, you can have that. We're going to the lecture. It's the pediatrician, who's Isaac Berger's pediatrician, is going to come down from Des Moines and give a talk in the math modeling class. And Heidi Berger invited everybody who's interested in pre-health. So molecular genetics, we're going to go over.
Will you